Welcome everyone, Alvaro Zamora here with IT Gigs from the Capstone project of USF Tampa Spring 2019. I have Joyce with us. Hey Joyce, how are you?
I'm doing good, Alvaro. Hey, how are you doing?
Good, very good. Thank you for being here with us and tell us a little bit, what is it that we're gonna go over on our video?
Okay, so we are going to go over how to create the player and how to get the movement in the player, and also how to incorporate the Google VR SDK into our player.
Okay, no, sounds good, sounds good. So we can see our guy Mega Man moving in blue down there on the screen. So we have on the left
Yes.
design window, on the right we have the game mode version window. So let's jump straight into this.
Perfect.
Sounds good. Let's look at what we got on the player script here and how we define this guy to be able to move. So first,
Okay, alright.
it's very important, Joyce, to have using Unity Engine here because it's going to allow us to access all the components that Unity offers and also the methods that they have defined in order to easily, code what we need in the game. So we start in the player class, right? That's the name of the script, and we have four parameters here from variable. Well, yeah, some parameters already defined. Speed, jumping force, rotating speed, and can jump, which we'll be able to use in order to make our methods work and make our player move in the virtual world. So as you guys can see, we have them defined as public. This is very important because if they're public, then that means that we can access it from the Unity interface, right? And we also can change it in real life. And when we're in the game mode, we can change this up and down. So we're able to do this once we declare those variables as public. So that's what is important, and that's the benefit from having them as public.
Okay.
Then it's very important to know the difference between, or the two most important methods in Unity when we're creating a game is the void start and the void update method. And so start pretty much is whenever you start in the game mode, whatever you have instantiated or created here or initiated, then you will see it. But as we don't want anything but the objects already in the virtual world there, we don't have anything. So really, this actually we can remove, and we will do so in the next video. And then we have the update method. So the way this method works is that it is called every time we have a new frame, right? So every time there's a new frame, again in computers it's like 20, 40, 60 frames per second. So every time a new frame in the game is happening, then we're gonna call this method. Okay, and this is important to know because we'll see it eventually in one of the questions that we got on one of our blogs. And so we see the logic is pretty similar for all the movements. I mean, of course, the direction would be different, but so we have the input. Well, why do we have the input get key here? Can you tell us?
Okay, so the input.getKey is basically the input that we get from the user. So that's the input function, and then the .getKey is the keyboard keys that the user is going to use to move the player around.
Exactly. So as we said, so Unity provides us with some already defined methods and keywords. So right, left, up, down, space, all of this are defined by Unity, so we can access it. When we do input, we read what the user is giving us. Get key is simply collecting that input from the keyboard. And so just to point out the difference, we have get key, which is a continuous key press. So if you hold the key down, then the input Unity will continue reading that input. Versus if you do get key down, then the key needs to be released before the next input is read by the Unity engine. Okay. So as we said, so transform is one of the most important components that we have in Unity. So knowing what can we access and how to alter the positions and the different values there is important. That we see transform is important because once we move a player, so if you use a player, those values are updated constantly. So we need to be able to access those in order to make the player move, in order to make the player jump, in order to make the player rotate. So that's the importance of the transform, and we're gonna use this in all the methods that we are applying to make the player move. So we access transform position. In this case, right and left is only rotating our players in the Y axis. So this is gonna work kind of like a go-kart. So you're gonna either rotate left or right, and then we have the forward function that is gonna take us there where we're looking at. So we have defined the vector. Again, you need to define. And vector make us access, instead of using a mathematical algorithm that it could be complicated, it just easily take us to the vector that we need. In this case is the up vector, because we're rotating the y-axis in order to make the rotation happen. So real quick, let's go to Unity. So once I'm moving, this is the y-axis. So once I'm moving right, I'm adding. Once I'm moving left, I'm subtracting. So that's what we will see in the method, that in here we have rotating speed as a positive number, and on the left we have it as a negative number. Okay?
Okay.
Now.
Okay. I have a question. Quick question. So regarding so next to the rotating speed, you have it multiplied into time.delta time. So what exactly does this time.delta time refer to?
That's a great question, Joyce, and that's actually very relevant to those gamers out there, game developers. There, so every machine has a different processing power. It could be, and what we talked earlier about the frames per second, right? So if you have a good machine, a powerful machine, you're gonna have more frames per second than someone with a slower, older machine, right? It's gonna have more frames per second. For example, a very good machine, I hear it could have 60 frames per second, versus, let's say, someone that doesn't have the best out there, it could be 20 frames per second. Now, we want to avoid having, we want to avoid an advantage or disadvantage on either way, right? So in order to do that, we have this time function, which is simply giving us the time, and delta time gives us the time between one frame and the other. So it's very simple. Faster computers have a smaller gap between frames, a smaller gap in time, so the number is going to be smaller. And slower machines have a bigger gap, right? So if I have 20 frames per second, there's a bigger gap between each frame, and that number is going to be bigger, and the multiplication, therefore, is going to be the same no matter what machine you have. Therefore, the movement would be on different, either if you're in a powerful machine or a slower machine. So this is necessary in order to avoid any disadvantage. So that's a great question.
So that basically is referring to, so it works hand in hand with the operating system and how long the operating system is taking the time to process.
Exactly. So it's important concept to understand when you are creating games and when you're working with Unity, definitely, because otherwise you will see differences. And if you're playing online, then one player will be moving faster than the other. So we want to avoid that to happen. Okay.
Definitely. Okay.
Then last one is the jump. So we have this is a little bit different. So we have a get key down because we don't want it to be able to do double, triple jumps like in Super Smash Bros. And we also want this to be true. So it starts as true, but we want it to become false once you jump and turn back into true once you hit a solid surface. So that's what we access here, the rigid body, which gives us the physics in Unity. Then we hit add force and jumping force only in the Y because we're going up, and then it becomes false. Then we go into this other method, collision, on collision enter, which is gonna change to true once if we hit a game object called, in this case, master town plane, because it's the name of our plane where we have the objects in the virtual world. And so that's all about moving the player around. And can you tell us a little bit about how to give the VR headset sensation to the player?
Definitely. So now that we have the player movement, we'll take a look at how to incorporate the Google VR SDK into the player.
Okay.
So the first step before incorporating is to download the Google VR SDK for Unity and import that into your project. And once we have that folder imported into our project, we can, within that Google VR folder, there are two prefabs which we are going to use for this player movement. One is the GVR editor emulator. It is within the prefab folder, and then the other one is the GVR controller main. And so, as we can see, we have already added these two prefabs to our player, Mega Man. And so now we'll take a look at how these work. So once we click play and are in the game mode, we can use the Alt key on our keyboard and press down the Alt key and move our mouse around. So, which gives you the 360-degree view.
Okay.
So you can look.
Yeah, like
right,
you
down,
have the headset on,
up.
right? Like
Exactly.
okay.
So it's like as if you had the VR headset on and we're looking around, so you can get the 360-degree perspective.
Amazing.
And then another function is if you hold down the control key on the keyboard and move your mouse left and right, you get the sensation as if you were tilting your head, sideways.
Oh, that's pretty cool. That definitely I think gives a more immersive experience to the player.
Exactly. So it's as if you were actually, had the VR headset on you and you were looking.
Yeah, no, that's great. I like that because the player would get a sensation that he is actually or she is actually there and can move naturally. So it's important to have this for the immersion experience. So I think it was great having you a good lesson. I think on the next video we're gonna see how the player interacts with the objects around it, and we'll see that. Joyce, thank you for being here with us. Always a pleasure having you.
Thank you. It was my pleasure talking.
We'll see you soon.